In part 1 of this lecture, we discussed how to develop an integrated project organization for effective communication and collaboration. We have argued that communication and collaboration should be at the right level of integration, so that there will be no frustration for the higher level people and no confusion for the lower level people working on our project. In addition, due to the complex nature of the project organization and the amount of issues managers need to deal with, it is necessary to design the project organization in a way that focuses their efforts on the key issues. Technology clusters is an integrated project organization approach that is led by the design requirements at each stage of the project and focuses on the technologies that need to be interfaced with each other. Thus the name technology clusters. In simple terms, this is about subdividing a project around its interfacing technologies to have a better focus on the key problems on time. What we are seeking is quality construction within the constraints of time and cost requirements. At the end of the day, you cannot build any part of building unless these interfaces are coordinated and buildability, safety, etc. problems are resolved. Still, in order to achieve 3-0, these issues should be dealt with on time so that there will be no interruption to work areas, delays, or rework with the consequence of standard quality. Although technology cluster can be implemented under whatever procurement approach, however, the procurement strategy has to be designed to facilitate the timely involvement of the STCs and the full integration of the supply chain. Therefore, to achieve 3-0, an integrated management framework is required, where the design is led by the work area requirements, the project organization is focused on the interfacing technologies and led by the design requirements, and the procurement strategy is led by the technology clusters requirements and aids the removal of barriers to efficient and quality production. So let us see how this works. The idea of cluster organization is not new. Mills in 1994 argued in his book The Rebirth of Corporation that modern technology and changing economics are forcing corporations away from traditional management models. He introduced the cluster organization, which combines individual creativity with teamwork. The cluster organization reflects basic changes in decision rules and the role of managers. A cluster comprises people drawn from different disciplines who work together to complete a mission, and its purpose is to create and exploit competitive advantage. Technology clusters approach is the adaptation of clustered organization in the construction industry. A technology cluster is part of a building that has to work as an entity. You can effectively draw the line once it's finished and move away from it. All the people involved in the cluster need to work together to make this approach work, i.e. achieving 100% completion of a defined subset of technologies that form a complete section of the project. For example, a cluster could be the structure. Structure these days are hybrid of steel and concrete with all sorts of different organizations involved in the design and construction of this part of the building. Typical clusters of a building could be substructure, structure, services, finishes, and envelope. Now let us discuss the key aspects of a technology cluster. Technology clusters are vertically linked value chains. What does this mean? People create values when they produce ideas or products or provide services, etc. The value chain of any building component develops vertically from a concept to an installed product on site, while the usual integration of the project team is horizontal, i.e. the client team works on their own, the same with the designers and others. When creating your project organization, you need to acknowledge the vertical development of building components in order to preserve the value chain and eliminate the loss of value, a rework, or unnecessary iterations. Technology clusters approach addresses this vertical development of building components by breaking the team and reorganize them around the interface in building systems and elements. In a technology cluster, focusing the attention of the team on a building component, the client briefs the designers produce the design, the package managers facilitate the transfer of the design information to the STCs, and finally the STCs detail these components, manufacture it, supply it, and install it. The integration of the design team with the STCs ensures that the value requirements created by the design team are conveyed to the STCs continuously, and the production requirements are considered as early at the concept stage of the project. In this way, there will be no loss of values in rework or substandard quality. When designing a project technology clusters, at each stage of the project, you need to understand the product, the process, and the organization needed to deliver this product. What we mean by that is, for a technology cluster team to function and collaborate effectively, and to fully complete each stage of the project and produce the required products, the right combination of designers, managers, and STCs should be involved to contribute their knowledge and skills on time. Therefore, the project manager needs first to identify the product, say designing the steel frame. To design the steel frame, the necessary knowledge and skills must be brought together. For example, about the facade, the floor covering, the ducts, the suspended ceiling, the lightings, etc. Who is going to contribute this knowledge and skills? Example, engineers and facade STC. What are the activities they need to carry out to produce the required designs? Example, designing the facade fixing to the concrete steel deck. The interaction requirement of those with the knowledge should be established. Example, suitable procurement process, such as pre-contract service agreements. Also, the time required to produce the product should be allowed in the program. The process should be designed and set in a way to enable the activities to be planned and executed following clear procedures. The organization design should place the contributors into a project-based structure that allows clear communication at the right level of integration. For example, if a decision has to be made at a higher level of integration, say the lead designer level, and only a junior architect is available in the meeting, the interaction with the team will be ineffective. As the project develops, the cluster team grows and more people are involved as the need for more knowledge and skills emerges. So the integrated management framework should develop accordingly. At key stages of the project, the integrated management framework should be reviewed and updated. When developing a project organization, the level of involvement and the dominance patterns should be understood. The level of involvement of the individuals and groups differ from one stage to another. At the beginning of the project, the client involvement is high, while the STC's involvement is high at later stages of the project. In addition, at the beginning, the project involves only few people, and the interaction requirements are straightforward. As the project develops, many more people are involved, and managing the interfaces between the various people and organizations become more complex. At each stage of the project, there is a dominant party. At the inception and concept design stage, the client dominates the process, supported by the architect. The project manager is there in the background facilitating this, but the dialogue is mainly between the client and the architect. This situation changes as the design develops and the designers become the dominating party during the scheme design stage. During the detailed design, manufacturing, and construction stages, the managers dominate the process. The project manager has to understand what happens, what are the expectations at each stage, whether there is a disruptive or integrated project organization. Example, are the architect dominating the consultant detailed design, while it should be by the managers? What happens often is that the architects, being the face on the project, know a lot more about it than the managers who get involved later in the process. For the project managers to fulfill their role, it is crucial that they thoroughly inspect the project once involved and take full responsibility and control of the process. This is an example of project technology clusters. This was a 21-story office building that is composed of 6 large cubic shapes stacked on the top of each other, asymmetrically, and rising up as a series of garden terraces. This shape added to the complexity of the design and construction of the building. Example, the directions of the services change every few floors when the building moves up from one cubic to the next. This project and other complex projects we looked at group the STCs into teams of interrelated technologies. In this example, the project was organized into 5 technology clusters. structured and temporary work, envelope, building services, finishes, and logistic and site management. Usually, each STC on their appointment to a project, they provide the organization chart of the team that is going to work on the project. These charts meant to assist the project manager in knowing who is doing what on the project and making sure that each STC assigns the right number of people with the right set of skills to the project organization. For the STCs listed in this slide, I used their organization charts to produce the integrated organization chart for each cluster. So let us see how these technology clusters looked like. The example shown on this slide and continues to the next is the result of plotting the building services organization charts provided by the STCs into the technology cluster template. These are mechanical installation, ductwork, electrical installation, lifts, wet risers and sprinklers, fire alarms, and BMS. This exercise revealed the problem of the organization charts provided by the STCs. The boxes where the font is in red is where there is a missing role. Example, there is a gap at system and detailed design of the mechanical installations. These gaps indicate missing skills that will cause problems and confusion. The dark green box is the required building services technology cluster management role that is missing also from the original cluster organization. So what are the implications of this gap of the technology cluster management role? Let us look now at the management roles at level 2, 3, and 4 in the current approaches. The design manager role is concerned with coordinating the consultant's design for the whole project. Each package manager is responsible for the design coordination of their relevant packages. The management on-site role is concerned with coordinating site activities. There is a split between the coordination off-site and on-site activities and between the consultants and the STC's design. This split causes often problems. For example, some important issues might not be communicated on time, or decisions are made in isolation of others. In addition, this situation creates a bottleneck in the communication lines and lack of focus at the design management level, as you might have noticed when you analyzed the steel frame organization chart earlier. All package managers have to go through the design managers to communicate and coordinate their packages design with the consultants and other interface packages. This is to explain more the management split we just discussed. In current project organizations, there is a management gap between the design manager and the construction manager on one side, and the package managers with their assistants on the other. Technology cluster approach brings the design management and the construction management one level down to become part of the cluster, filling this management gap. By breaking the project organization around a set of interface technologies, i.e. clusters, the management effort will be focused on the issues related to the cluster. The cluster manager, who has the management skills and the particular technological knowledge of the relevant cluster, is in a way a project manager of a sub-project, i.e. the cluster. He or she is supported by package managers who are responsible for each STC package in the cluster. In the services cluster example we looked at, the building services cluster manager should be knowledgeable in building services relevant technologies. He or she is supported by package managers who are responsible for the following packages: mechanical installations, ductwork, electrical installations, lifts, wet risers and sprinklers, fire alarms, control systems, and BMS. The cluster manager would be chairing the meeting with the relevant designers and provide senior leadership for the packages, removing the bottleneck discussed previously. The management cluster includes the client, the designers, and the managers. These three groups, although they are represented in each of the project technology clusters, would be dealing with strategic issues and plans, handling the interfaces between the clusters, doing trade-offs, and making sure all key issues between the technology clusters are raised and dealt with. At the outset of the project, the management cluster would define the project clusters, the roles and responsibilities, and set the framework for collaborative working. If we take the services cluster as an example, As the project develops, the management cluster would set the big sub-goals of the services cluster within the overall goals of the project. The structural cluster would advise on the structural issues related to the services. The management cluster would monitor the interfaces between the structural cluster and the services cluster, do the trade-offs, and make sure all key issues are raised and dealt with on time. No two projects will have exactly the same clusters. The division of the clusters is a matter of discussion and debate as to what is included in which cluster. A cluster contains all components that, when integrated together, complete a section of the building that can be signed off. Plant rooms, for instance, can be tested as they can be isolated from the distribution system. However, until the risers are connected, then the whole system cannot be tested. Depending on the project, is whether the plant rooms becomes a cluster or whether the whole services system becomes a cluster. The cluster should integrate the whole supply chain for each component included in the cluster. In addition, how the design or modification of one component affect the design of other components should be considered. Components that have many interfaces between each other should be grouped together in the same cluster. The interfaces between clusters, say between the structure and services, should be minimal and simpler to resolve. The remaining interfaces between clusters could be coordinated when is needed. There is no absolute division, as it depends upon the situation, design of the building, and how best to subdivide the management of the project. However, understanding the need to have clear lines of responsibility for integration and delivery of the subsections of the building is fundamentally important. In summary, technology clusters' approach to project organization could be described by these 5 points. If you are interested to learn more about this approach, you can visit 320 website.